So for those of you who do not know us, the Life Science Cluster is a national cluster with over 120 members. We are a non-profit and a public-private member organization working within both health and bioindustrial solutions. I will talk about two of our main focus areas here today: better utilization of biological resources and also sustainable food and feed production. Additionally, we work within global health challenges and development of new pharmaceuticals. And we think there are a lot of potential for collaborations between these different sectors. And we work on making the road from idea to market easier and faster, eventually creating new jobs, and also, of course, improving the quality of life for individuals, both nationally here in Norway and also globally. We do that by strengthening interaction between academia, industry, government, and also investments and capital, with our goal to create new solutions. Now, this is our team. I'm here today as the event and communications coordinator, together also with Delphine, our CEO. You can reach out to us if you want to get in contact. And I think I'll give the word now to Jan Erik. We'll give a couple of words about Nofima.
Thank you, Benjamin. So first, I would like to thank you for taking this initiative. It's important for us to play an active part in the innovation environment in Norway, not least because of the infrastructures we possess, which are ideal to support new industry and the growing circular economy. So before the Aquafeed Technology Centre and Biotep presentations, I will give you a short introduction to Nofima and who we are. We are an applied research institute. We conduct research with the aim of developing knowledge and solutions that strengthen the food industry, support the public sector, and also benefit society in general. We are one of the largest food research institutes in Northern Europe, and we work to promote sustainable food production and innovation within aquaculture, seafood industry, and traditional land-based food production. Some key figures from last year: we had almost 550 active projects, collaboration in 34 countries, 387 employees, a majority of them are women, and 167 of the employees hold a PhD. We had an annual turnover just above 700 million NOK. Here we see a map showing the countries we collaborate with. Our global network enables us to share knowledge and technology across borders, supporting best practice in R&D and innovation. Our majority owner is the Ministry of Trade, Industry and Fisheries. In addition, we are owned by the Foundation for Agricultural Food Research and Aqua Invest Møre og Romsdal. Although we have a governmental majority owner, we compete on the same terms as other research institutes, such as SINTEF and NORS. We mainly finance our activity through competitive project calls from instruments such as the Research Council of Norway, the Norwegian Seafood Research Fund, and the EU. Here we have the organizational chart. You don't have to memorize it, just to show our structure. We're structured in 3 divisions: aquaculture, seafood, and food science. It's important for us to interact across divisions and departments to utilize our expertise as best as possible. This interdisciplinary collaboration is a great strength for us, and it ensures that we can deliver high quality research and by that achieving our strategic goals. We have 5 main locations. The head office is here in Tromsø, where I'm situated. This is also the main seat for our research into the seafood industry. At Ås, we focus on agriculture-related research and food science in general. Bergen is our Center for Feed Technology, which you will hear more about soon. In Stavanger, we work a lot with food products close to consumers. This location is known for their work in improving quality and safety of food products through advanced processing technologies. We have, for instance, been involved in developing the Fjordland products here. And on Sunndalsøra, we have a research station where we do, for instance, fish trials. Here we see Åsa and Per, who work in the aquaculture division. Although a broad research portfolio, we focus a lot on improving farming methods for fish and shellfish. We work with everything from genetics to feeding strategies to support sustainable growth in the aquaculture industry, which is a hot topic nowadays. The seafood division collaborates with the fishing industry to develop technology and knowledge. We research fishing methods, quality, framework conditions affecting the fleet, and we also conduct background investigations for the Ministry of Industry and Fisheries, which they use for making the necessary regulations. Runar and I work in Marine Biotechnology department, where we develop products from marine resources such as residual raw materials and macroalgae. And Biotep is also part of this department. Food Science division focus on land-based food from production to finished product. I would like to especially mention that this division has a trained sensory panel of 10 super tasters who assess quality and use their skills to, among other things, identify issues in production chains using smell and taste. That was a very fast overview of what we do. So then I think I will leave the floor to Tor André Samuelsen, who will continue with his presentation.
Yes, thank you. I will share. Just move this like this. Okay, good morning, everybody. I will now give some information about the bioprocessing and extrusion possibilities at the Aquafeed Technology Centre. But before I present the center, I just want to put it into a context. So far, the replacement of fish meal in salmon feed in Norway has been performed with the use of plant proteins like soy protein, concentrate, and wheat gluten. And they are from seeds, so they are relatively dry. So that means that they can be processed with a relatively low heat load and have shown to have high digestibility. Then we have this new mission, the Norwegian government social mission on sustainable feed, where the suggested new raw materials are, for instance, like blue mussels, tunicates, algae, insects, and single-cell protein. And this requires more processing to turn them into high-quality feed ingredients. And this include heat treatment and separation, which actually may impact both the nutritional and technical quality of the ingredients. So why do we need heat treatment? First of all, we need heat treatment because of hygienic requirements to eliminate bacteria, mold, and yeast. And we also need heat treatment for separation, for instance, turning insects into a protein ingredient. You need to separate it to oil, solid, and stick water before you are making the final product. And also stated in the report, A samfunnsløft of bærekraftig fôr, heat treatment due to drying and drying optimization will be very important for successful ingredient development in the future. So what is then the challenge? That is that heat treatment may impact the digestibility and the technical properties of an ingredient. So to process these new raw materials into ingredients and feed and further characterize the products both technically and nutritionally is what we can help you with in the Aquafeed Technology Centre. The Aquafeed Technology Centre is a research infrastructure that was established from 2017 to 2021. Then here we renew all our laboratories and pilot scale facilities for process and product development. The center is hosted by Nofima and is a collaboration between the University of Bergen, Norse, and Nofima. And Nofima's part is situated in Skjæredviken in Bergen. Here you see a picture. And there we have process laboratories, for processing and extrusion. We have pilot halls, you see them here, for processing and extrusion. And we also have established analytical laboratories for measuring physical, chemical, and rheological properties and visualization. At the Aquafeed Technology Centre, we have a value chain approach. We can process any kinds of material by use of enzyme technology, separation, extraction, concentration, evaporation, drying, and we can further process these ingredients by use of extrusion technology into texturized product. And then we have analytical product platforms to characterize our ingredients and feeds. And we can also document nutritional quality at, for example, our research station for sustainable aquaculture at Sundalsøra. The Aquafeed Technology platform is mostly into feed, but we also work in the food segments. And we actually have a lot of projects on food ingredients, marine food ingredients, hydrolysates, and also texturized products. Okay, I will start with bioprocessing and process technology. As I have said, we can take any kinds of ingredients. We can turn them into intermediate products and end products, including mass balances and finding the best processing routes. And the end products can be powders, concentrates, hydrolysates, silage, and oils. So we have actually a broad competence and lab and pilot equipment, as I have told you, for processing of biomasses into feed and food ingredients. We have worked extensively with marine products like pelagic fish, mesopelagic fish, fish byproducts from both salmon, pelagic, and whitefish, krill, calanus, polychaete, tunicates, and we have a large ongoing project on blue mussels. We also have a large ongoing project on poultry byproducts. We have worked with insects and micro and macro larvae. And here we see the picture of our pilot hall for wet processing, including tanks for hydrolysis, trichanter separation, membrane filtration, and evaporation. Just an example of use, we have a large project called Mussel Up. It's a FHF product together with Institute of Marine Research. And our work package is to find the best processing route for turning blue mussel into a highly nutritious protein ingredients. So far we have worked with both the silage and the fish meal process in lab scale. We actually have prepared 18 samples by use of different processing routes and, important, varying heat load for digestibility evaluation. And now it's an ongoing in vitro testing at IMR. And next year we plan to, based on this in vitro testing, to upscale the best production trials at IMR. So we plan to do a digestibility experiment springtime on salmon, where we plan to process blue mussel in our pilot plant. And then we plan to have a long-term feeding trial at the end of the year, where we plan to process higher quantity, actually at Biotep. And that leads me to the next slides, because the Aquafeed Technology Centre and Biotep fits very well together. You can play around in lab scale, lower than 5 kilo at the Aquafeed Technology Centre, and a smaller pilot scale production. Then you can, when you have played around here, you can upscale your best product in a demo and production scale at larger scale. And Biotep is also food approved, so you can also take all your products into the market. And then a very important part of the Aquafeed Technology Centre, it is extrusion technology, where we can formulate ingredients into texturized products. The materials can be powders, wet products, concentrates, oil together to make feed, snacks, cereals, and meat analogs. And on this picture, you see our famous sea urchin feed. It's actually licensed to Oceanomics now worldwide. Here we see salmon feed, and here we see snacks, where seaweed snacks, and here we see a texturized plant protein meat analog containing fish. At Nofima, we have both lab and pilot extrusion facilities with all the processing steps needed for feed production, as milling and sieving, mixing, preconditioning, extrusion, drying, and vacuum coating. And this last one is very important to achieve the high fat content needed for salmon feed. And in 1.5 months, a brand new pilot scale preconditioner and extruder will be installed. So now in December, all this will be removed. And this is actually the largest single investment Nofima has ever made. So we really look forward to starting to use this equipment, this new equipment in the end of February. Just an example of use. Here we have replaced fish meal and soy protein concentrate with tunicate as a protein source in diets and extruded them into feeds, as we see here. And we see that the tunicate meal gave more expanded feeds with larger pores. This is pictured from our CT scanner, and these dark spots are air. That means that it absorbed much more oil during vacuum coating, but due to the high expansion, it had lower physical quality. But the experiment showed luckily that we could replace 50% of the fish meal with this new sustainable tunicate meal without compromising physical feed quality. That means approximately 16% with 32% fat in the feed. So what we see is that ingredients affect the extrusion process and physical feed quality. And this is also important to know together with the nutritional quality of the ingredients. And then at last, we have product characterization. We can characterize any kinds of ingredients and product. We can characterize it chemically and microbiologically. That we can do at our accredited laboratory Biolab, which is also situated in Bergen. And we can do sensorial analysis at Nofima Ås. And we can do physical and mechanical analysis in the Aquafeed Technology Centre, like looking at rheological properties, powder flow, pellet testing, visualization, water absorption, and so on. So just an example, we have instrument for physical and rheological analysis. We can measure bulk density and powder flow, how well the ingredients are flowing in, for example, a feed factory. We can measure viscosity, both in a wet state and in a drier state. We can look at glass transition and flow transition temperatures, which is very important for the extrusion process. We can measure viscoelasticity in feed and meat analogs, water absorption, water activity. And we also have instrument for feed analysis, that physical feed analysis, that hardness, durability, water stability, fat absorption leakers. And we can also look at pellet pore size distribution by use of our CT scanner. And just an example for use, it's a little bit complicated, but here we see the results where we analyze temperature change for flow through a capillary dye, depending on the raw material and water content. And related to the extrusion process, we see temperature, moisture. We see that soy protein concentrate needs much higher temperature or much higher moisture for successful transformation from a powder into a durable feed, compared to fish meal and wheat gluten, which is relatively easy to transform with the temperature and moisture contents you have in the extrusion process. So this is how we can relate analytical and rheological analysis into the actual extrusion process for making feed. And that was all I had. And I just have to say that in March 23, the Norwegian Crown Prince visited us, and we had a very interesting discussion about future ingredients. And we also got the possibility to tell him, as I tell you, how the Aquafeed Technology Centre can be part of this development. So thank you for your attention. Should I just stop sharing or wait for questions, or just
yeah, you can just thank you, Tor Andreas. You can just stop sharing,
yes.
and I think we'll move on to Runar.
Yes.
And then we'll do the questions in the end.
Yes. Okay.
Yeah.
Thank you.
Sure. Just let me get my presentation on. So yeah, I assume you can see it now.
Yeah. Good.
So I'm going to present Biotep, which is quite similar to the ATC, but on a larger scale even. Biotep is primarily used by aquaculture and fisheries industry. So all of my examples will be from there. That's also because we only allow marine samples and vegetables and stuff. So we don't allow any terrestrial meat samples into the Biotep facility. And yeah, it's everyone going there works with fish somehow. I do that too. And while most people wish to work with what gives you the highest income, I tend to look at what has the highest potential or the highest unused potential, if you will. So guts, entrails, heads, skins, they all have proteins, they all have fat and stuff we need. So it's a good approach, or it's a smart, intelligent solution to actually start working with the side streams, as we call them. They're also known as byproducts or co-products, but they all mean the same. They're not the main item. So that's what I'll be focusing on, and which is also the most common input at the Biotep facility. So the question is, what do we do with it? So the premise here would be that whoever's going into Biotep has some available marine or plant-based byproducts, co-products, side streams, a desire to exploit it, and preferably a certain flair for innovation, I guess. We will have the knowledge about process if that's necessary, but the lead character here is obviously Biotep, which is the national facility for bioprocessing. And the reason we think it's a good idea is so that whoever needs it will not have to spend 100 million NOK in investment just to make their own factory. So I think basically we can perform a production for less than your interest rate if you were to build your own. And the focus here is on product development. Let me just put this into some context for you. So the amount of side streams generally available. Let's say you're a fisherman and you go out fishing cod. You have 1,000 kilograms in your catch, 1,000 kilograms of cod. Out of these 1,000 kilograms, 570 kilograms would be your main product. So a bit above 50% is your main product, whereas 430 kilograms would be side streams. So it's a huge untapped, but still very much available resource. And remember, you spent your man hours, your resources and fuel just to extract this cod from the ocean. So it's important to note that Biotep does not exclusively allow side streams. It's not a rule, but the main product is often sold at a good price anyway, so it's not necessary to do any processing there. And yeah, so I rarely know the level of my audience. So now I will just take you quickly through the process, how we would normally do it in layman's terms, I guess. And I guess if you already know this, you can watch YouTube or something, but come back in a few minutes. So I will try to answer what's contained in the side streams and what to do with it, and our most common approach to increase the value of it. So the easiest way is to take side streams and place them into a reactor. We add some water and enzyme, and then we see what happens. The enzymes are sort of bioscissors or biomincers to make an homogeneous mass and facilitate the separation. And the enzyme will also liberate the different classes of compounds. And when I speak of classes of compounds in this context, I mean water, oil, ash, and proteins. That's generally how we evaluate any edible biomass. And side streams will have different amounts of each, and enzymes will help the proteins dissolve into the water, and that will make a phase together, and the oil will make another phase. And we separate all this by centrifugation. So we spin them quickly, and the oil places itself on top, water and protein in the middle, and then you have a sediment of undissolved protein, some fat, and some miscellaneous. I'm just quickly going through the process, and we'll get to Biotep shortly, so don't worry. Most people use enzyme to break down their material. The reason for this, it gives the best flavor, and human consumption is by far the highest paying market. So that's where you want to aim to be at, because if you spend resources on process, then you should have the most ROI of that investment. Yeah. But this begs the question, which enzyme? So there's an enormous diversity in enzymes. You have some that have very high yields, meaning that you will get a lot of proteins out of your side streams. You have some that will give good taste. You have some that will have a specific point of cleavage, meaning that they will look for certain amino acids in your proteins. And this image is just like a current selection we have in our lab. I took it a few weeks back. And then your next question is, what is your end product? What are you aiming at creating when you get to Biotep? Is it an oil or a powder, perhaps a concentrate? Turan also talked about this previously. You have different end products and different sort of approaches to maximize that end product. But let's recap. So you do perform an enzymatic hydrolysis, and then you do a separation. You get the water-soluble proteins in water. You get the oil and the sediment, and you need to decide which is your preferred end product. So oil is full of energy, and marine oil is very much sought after in most markets. Proteins, it's a winner for any food, actually, I guess. Yeah. But let's assume that you have everything I talked about. It's in order. You know how you know which process you know where you want to be at. So let's assume that everything is known. Then what? Now comes the scaling up, where we make a product in the demonstration plant that can be sold. And this is important. We're approved for creating food items, food stuff. And that leads me to Biotep, which is the demonstration plant we have, which is the larger of the two. So the Turan explained the ATC, and I'm here to explain Biotep for you. Let's start with the most concrete. How much side streams will you need to have in order to have a feasible production in our facility? So the minimum amount is 800 to 1,000 kilograms, and that is that's the bottom. Any less than that, there's no point. It's going to be too expensive, and you'll have not enough output. And from there, you can go all the way up to roughly 25 tons in 1 week production. So our production is 24/7-ish. We start Monday morning at 8, and we can run the facility all the way to Friday afternoon at 4. And we run at 4,000 NOx per hour, plus variable costs at 1,000 NOx per hour. But let's go even more concrete. So I asked one of our operators at the facility to make an estimate. What would a general production look like of 800 to 1,000 kilograms? And he said that would be 26 hours and looks something like this. So Monday at 8, we have the grinding of the biomass. At 10, it's in the reactor. We add the water, like I showed you previously. At 11, the heating is complete. We we add roughly the same amount of water. So if it's 1,000 kilograms of biomass, it's 1,000 kilograms of water. So 2,000 kilograms needs to be heated to the correct enzyme temperature. It's going to take a while. But let's finish at 11. And at 2, the hydrolysis is complete. At 3, we start separating. All of this I showed you previously. And at 5, we start the evaporator. The evaporator removes some of the water to create a concentrate. And at 6, we start the spray dryer, which creates the powder, assuming that that's what we're here for. And at 12 in the evening, the spray dryer is finished. And Tuesday at 10, the factory is clean. So it's 26 hours total production. And what you have now is your raw material broken down by enzymes, dried to a powder that you may sell to any potential customers. And also from the separator step, you have the oil from your biomass. If you have a fair grasp on all of these issues that I mentioned, and you have marine or plant-based side streams, I would suggest just call Biotep immediately and start from there, start a process. It's a relatively small investment to make an actual product, fit for market product or ready for market product, I would say. If you don't have a fair grasp on all of these issues, that's no problem either. I mean, you can call me. We do contract research as well. We do the small scale in the lab. We can problematize together your process and create your process together. We have a lot of knowledge on these things, and together we can make you ready for Biotep. And yeah, this is I'm just going to show you 2, let's call them success stories, before I will show you a film towards the end. So this is Marialis. They create a hydrolysate from shrimp shells, shrimp peels, and that is sold as a supplement for retaining a nice blood pressure, I guess. And we also have Suka here, which is a company that looks into the Colonus finmarchicus, which is a tiny copepod, and it does have some oil in it that they have performed a lot of clinical research to find whether or not it's beneficial. And lastly, I would like to show you our Biotep film. Can you please, Benjamin or Delphine, just shout out if there is no sound, because I rarely think these things work nicely. So yeah, just let me know.
It works.
that's it. Thank you.
Thank you very much, Runar. All right, and thank you to Tor, Andreas as well. We're now finished with the presentations, and we can open up for some questions. You can either write it in the chat or you can just unmute yourself if you want.
Please, not everyone at once.
Maybe while we wait for questions from the participants, maybe you can say, you were describing, how long it takes at Biotep, 26 hours for the process, but from a company contact you until you put that into place, like what are the timelines? How long does it take? And do you have a long waiting time?
If I assume you're asking me now.
Yes.
Yeah. So if the company has, it's a big difference between having your process established and not having your process established. So if the process is not established, then definitely there is a timeline getting to Biotep. So I would say 6 months to a year to establish the process, but more 6 months than a year, because these things work quite quickly. I mean, we are before we establish something. Whereas if you have a process ready and you have the side streams already available, then most of the time the sort of the limiting factor is actually logistics. It's how much time do you need to ship the biomass to our location, because we're quite flexible in our schedule, and I mean, there may be like a few weeks waiting time, but it's not daunting, at least.
Very good, very clear. I see that there came some question in the chat.
Are the feed ingredients mentioned during the talk has any biogenic amines? I think that would be for you, Toran.
Yes, and I think this is a question of freshness of the product. Fish has biogenic amines, and also chicken byproducts can have it. But if you are going to make a highly digestible ingredient, for example, salmon, it needs to be fresh, because biogenic amines, high amount, is a measure of it's a freshness parameter. So if it's high, the product can be spoiled, and it will not be a good product for the fish. So in one way, I think it's really important that ingredients are fresh before you process it. Yeah, but in one way you can stabilize it, as we see on blue mussel. You can stabilize it with acids. So in one way, it is you can stabilize your product before in one way or another. So but freshness is a key to a good ingredients for salmon, and for sure low biogenic amines.
All right, we have two questions more.
It says here, what is the commercial viability of these feed ingredients when compared to fish meal from customer standpoint? And could you please throw some light on the sustainability angle too? I think feed ingredients is it's mostly ATC, but yeah.
Yes, it's a good question. As I told, the transition from use of fish meal to more plant-based has gone. It has been challenged, but it has gone quite well. So now is the question: how can we process all these new ingredients into products that can be comparable in terms of digestibility, and comparable to fish meal and soy, because you need heat treatment and you need all these ingredients are quite wet, so you also need drying. But the fish meal industry has solved this, so we have a lot of competence in the background how to proceed with new ingredients and turn them into high quality products. And we also have a large starting a large project at Nofima, a strategic program where we actually are going to look at this topic more extensively. Yes, it is possible, but I think it's a challenge. Yes.
Runa, do you want me to comment on next question?
Oh, no, it's fine. Regulation question. Biotep work with animal byproduct, I assume. Is there any restrictions to produce feed and food using the same production line using animal byproduct? So first, I just have to make some clarification. We do not work with animal byproducts in the legal sense, because if you call something an animal byproduct, then it's not for human consumption. So if something is declared an animal byproduct, we cannot take it into our facility. But we work with side streams, and we used to call them byproducts before this legislation made it difficult to call them byproducts. So there is some confusion as to the terms, but no, we do not work with byproducts. So if that is your question, then the answer is no. But there are restrictions, yes. If we were to allow byproducts to enter the facility, I think I'm not sure what would happen. I guess we would be contaminated in some way and not allowed to produce any food items.
I should also just mention that we can make feed ingredients at Biotep, but it has to be food quality raw materials that enter the factory. And then afterwards, you can declassify the product from food to feed in a formal way. So it's possible.
And yes, we can actually process all kinds of ingredients, but we have a restriction on the pilot extruder that all ingredient has to be from approved suppliers. But we do not have that restriction on the small extruder. And often when you start with new raw materials, you always start in small quantities. So it in one way fits, because the small extruder you can use smaller amount of ingredients. Testing feeds. But at the large one, we have to. So in one way, if we want to make enough blue mussel powder for the production on a large scale pilot extruder, we have to go through Biotep on food approved mussels, for instance. Then we are allowed.
Okay, thank you. Can I just add one follow-up question? So with your example with the codfish, when you harvest and they come from the sea, they go back, you have your main products. With the rest of the ingredient, it's the fishery or the process factory that needs to provide Biotech with a certificate saying that this is for human consumption still, not animal byproduct, so that your factory can work with them.
I am not 100% sure of the actual how this process would look like legally, like what type of documents would be needed. But as a cod it's a food item, it's a food product when you fish it, so you can sell it as a food. So and that would apply to the entire cod. So unless the side streams are downgraded to a byproduct that would be a category 3 byproduct, then you don't really have a problem. So the problem is the moment you downgrade your side streams to a byproduct, because you can never upgrade it.
Yes.
Yeah. Rune, I can extrapolate a bit on that also, on how it's handled, because if you rent Biotep, it's you as a company that rent Biotep and the process operators. So this is regulated through the contract with you as the customer. So legally, you are the one doing the manufacturing because you own the process. We have some routines making sure that the suppliers take this responsibility. So in the end, you would be responsible to make sure that the raw material is of food grade quality.
Okay. And in a way, by regulation, if we are able to keep what was a food in a food standard in like a cold chain or in transportation, then we should still be able to declare it's a food ingredient, even though it's a byproduct.
If it's a side stream, not a byproduct per regulation, as Runar explained.
Okay. Yeah.
But the whole naming thing is quite confusing, and that's largely because we used to call the side streams, we used to call them byproducts because it's a good name and it was well established. And then you had the byproduct legislation, which more or less said that if you call something a byproduct, it's a byproduct, and a byproduct is not food grade.
Okay, so we should start calling them food side stream. It's
a side stream is a nice name.
Okay, thank you very much for the presentation and the question.
Thank you.
All right, we are a couple of minutes after, so I think we'll round it up now. Just for your information, we'll share your contact information for Jan Erik, Runar, and Tor Andreas, and also the recording and also the presentations as well. So you'll get that soon. And with that, I want to thank you to all participants showing up for today and the questions, and also, of course, to Nofima, Jan Erik, and Erik Jan, and also, of course, Runar and Tor Andreas. So I wish you all a wonderful day.
Thank you.
Thanks for having us.
Thank you.
Bye-bye.
Yes, bye.